Hi guys. Um, Previously I tried to solve this problem due to a acceptance rate 50%. Kinda difficult one. And then I couldn't solve this. I couldn't even find any hint. So embarrassing. So I read how to solve how to solve this. So let me explain how to solve this. So the approach here is to focus on the room, not the time. So for example, let's say that 25 and 40, and then uh, 30 to, let's say, 50. Okay. So in the case, what is important is that when a meeting is started, if there's any room left, that kind of question is very important. So for example, looking at this, we reserved the room for 1, and this, the first meeting was not finished. So by comparing the starting time and the meeting end time, we have to reserve the room 2 for the second interval. And then the third interval, when the time of 10, there is no meeting ended. So this will require one more room. So let's check like this. One more room, right? And then in here, 25, finally, when the time 25, at 25, we found that there are 2 rooms left. So previously we had a room, maximum room count 3, but now when 25 start, now we know that 2 rooms are left, so only 1 is using right now. So we remove these rooms, and then we add 1 for this, right? And then when the time 30 comes, we saw this and this, and oh, this is end. This just ended. So we can remove this, and then we can allocate the room to this, right? So the current room count is 2. So what is important here is first, the time order must be sorted. So when you see, I think if we see some kind of array or order, not ordered, not sorted, some list, first I have to think about whether it can be sorted. And it is complex data, not like just an integer data, but in this case it's pair. So in that case, we can think about how, by sorting, for example, by the first element or the next element, would the problem be solved? Is one of the things we need to think. So anyways, so this must be sorted, and then when a new meeting comes, what is important thing is that is there any previous meeting that ends earliest? So in this case, 25, we see, let's say this is 19 and this is 20, right? So in that case, this one first see this, and then this one can use the room, and next this room also be used. So the smallest smallest ending time is important. So when the smallest ending time for the meeting rooms is earlier than the new meeting, starting time of the new meeting, then you can utilize those rooms. So here, important thing is sort meeting by starting time. Then the next thing you can think about is remove the min ending times, which is smaller earlier than new starting time. Right? So what is the data structure to get the minimum value is a min heap, right? So this is the algorithm, and then the one inside the heap is the number of meeting room. So we can keep track of the number of the meeting rooms, and then we can return the maximum rooms. So here, first what we can do is that sort intervals and where sorting function is not int, vector a, vector int a, b, where a dot a0 is smaller than b0. If in this case, so this is the sorting function to ascending order by the starting time. And then for each interval in intervals, what you can do is that you can priority heap heap. So the usage of priority heap is kind of complex when we use it as a max heap, but in this case is min heap. So let's just, I think this will work. This won't work. Maybe we need to do this, possibly. So what I can do is that if in heap empty, which means that, and also we need int max count is 0. When min heap is 0, we can min heap dot insert interval. else. So we can so at the end, if max count max count and min heap count. So here what you can do is that auto row list equals min heap top. If row list 0, not 0, 1, and the time is less than or equal to interval starting time then we have to pop it. And actually this is while, because we have to pop until the earliest is bigger than the interval starting time. And then the next thing we have to do is that we have to add min heap insert, right? So it could be this while loop might not be executed because the earliest one is larger. In the case, for example, this case, this one is smaller. This and the top one in the min heap is larger than the starting time. So something like this. So and then max count we can anyway set the max count. If we add this into the min heap, the min heap size is 3, so the max count will be 3. Right? Something like this. If we maybe there was some compilation error. No template named priority heap in name. Do you mean priority queue? Yeah. And then there's no insert in the priority queue vector. Okay. Maybe push. Yeah. This is pushed. And max count. And then type 1 error. Oh. No member count, then probably size. No matching function for the call max. something is unsigned long, so maybe we can change it to unsigned long. Well, we have to check whether runtime error. Okay. Heap use after free. So this sort will be fine, right? And then this for loop is fine. Then when min heap is empty, we just push. When it is not empty, we see the earliest. Oh. So when it is earliest, when not empty, and min heap is not empty, and when min heap is empty, then we just go here. So and then we can here. You might not need this. So when min heap is not empty, so when min heap is empty, we just push. When min heap is not empty and not empty, if then we can get the top, and if earliest is smaller, the min heap pop. Right? And else will break. Yes, I guess this will work. So here this will be sorted like this. And then in a min heap, first 4, 9 will be added, and then 4, 17 will be added, and then 9 new is not empty, and then top is this one, or list is this one, and then list 9 is interval 0, so it will be popped, and then we'll add interval, this one, 9, 10. 9, 10 will be the top. So previously max count is 2, currently is also 2, but how come 3 is returned? How come 3 is returned? Min heap interval interval ending is less than, so previously was like this, since this is min heap. Oh, so yeah, I understand why this happens, because this min heap does not know that since it's the vector, it does not know how to decide which one is the smallest one. So we have to have some compare. You know what? I can just enter int here. So when we push, you can just do this, and because end time is important thing. Well, I'm not sure whether min heap is used this way. Is this max heap or min heap? I don't know. I don't remember. Probably this is max heap. Probably. So in that case, we have to use some difficult auto compare for min heap, compare int a to b, and then we have to return a, b, this is ascending order, so decal type compare, and then min heap compare. Not sure. Maybe this. So min heap. How to implement min heap? Priority queue. So by default is max heap. And the min heap greater PQ multiply -1 and then also does -1. Compare, yeah. Okay, so it's kind of hard to remember. If we use this inside the sort, then priority queue. Yeah, I guess this is it. So let's add some comment into here, and then let me finish this session. Okay, bye.